Okay, in this video then we're going to look at some different types of functions. Before we start though, let's recap on our definition of a function. So a function requires each input to have exactly one output. Now that may seem obvious, but let's just have a look at that on a mapping diagram. So here we have an input A that gives us two different outputs, P and Q. You'll come across a lot of mappings like that throughout the course. Things like circles have a mapping like that. But if we have one input that produces two or more outputs, that means that what we're dealing with is not a function. And so now let's have a look at some different types of function. First of all, we have one-to-one functions, also known as one-one functions. If a function is one-one, it means that if you have an output value, then there is only a single input value that could have generated that output value. You cannot have two different inputs generating the same output. Let's take a look at an example. F of x equals 2 to the power of x is a one-to-one function. If we draw a mapping diagram for it, we could take some input values. For example, 3. 2 to the power of 3 is 8. We could put in -1. 2 to the -1 is a half. And there are lots of other values that we could put into this function, but for every output we get, that must have been generated by a unique input value. We can perhaps see why this might be if we look at the shape of the curve. Notice that for the curve y equals 2 to the power of x, it's always increasing across the whole domain. If a function is always increasing or always decreasing across the whole domain, that means it will be a one-to-one function. Next, let's take a look at many-to-one functions. So if a function is many-to-one, it means that we have more than one input that produce the same output. This is quite common. For example, let's take g of x equals sine x across the domain 0 to 360 degrees. If we draw a mapping diagram, there are some outputs that can only be produced by a single input. For example, if we put 90 in, the output is 1. There's no other way of getting the output 1 if you restrict the input values to between 0 and 360. If we put 30 degrees in, sine of 30 is 1/2. Now let's think about what happens if we put 150 in. We also get the answer 1/2, and that means we have two input values that are producing the same output. That makes this a many-to-one function, and there are lots of instances on this curve where two inputs will produce the same output. Let's have a look at the graph to see why that is. So here's the curve sine x between 0 and 360. If we were to put in an x value of 30, we get a y value of 1/2. Now if we extend that line horizontally to the right, we see we hit the curve again, and that gives us an x value of 150. So this illustrates a more general principle, which says that if you draw a horizontal line across the graph, then if that line hits the curve in more than one point, then there must be at least two x values which produce the same output. We can formalise this using the horizontal line test, which lets us determine if a function is one-one. If we have a graph and we draw a set of horizontal lines across the graph, then if any of those lines meets the curve more than once, it's not a one-one function. Let's look at an example. Suppose we have a quadratic curve, in this case x squared minus 3x minus 8, where the domain is all of the real numbers. We can draw a set of horizontal lines, and we can see quite clearly that lots of those horizontal lines will cross the curve in more than one place. That means that this quadratic curve is not a one-one function. In a similar way, we can also use the vertical line test. This one tests whether a mapping is a function. We draw a set of vertical lines over the graph, and if any of those lines meets the curve more than once, then it's not a function. Let's have a look at an example to see why that is. Here we have quite an unusual graph. The equation is given at the top, and let's draw a set of vertical lines over this graph. Notice that in most places, the vertical lines only cross the curve once. However, there is a line that crosses the curve in 3 places. And because of that line, the equation that we're given at the top cannot be represented by a function across the domain that is shown on this graph.